I know we're all tired after this long day and probably a good amount of information. So two simple things, just watch. First is I will demonstrate one of our additional libraries, pedestrian simulation, and another one is rail yard library. Vladimir, maybe you can comment, because I think this is a kind of model close to the real projects you performed somewhere in France.
Yes, it was all the project for Saint-Charles, métro Saint-Charles.
Oh, you can talk French.
Ah, ok. C'était le projet de consultation que nous avons fait pour le métro de Saint-Charles à Marseille, mais c'était pas la réalisation du projet, mais c'était un des variables. Et le but de simulation était de vérifier les différents projets d'architectes, quand on change l'essence des escalators, escaliers, quand on place les distributeurs automatiques dans telle ou telle place, etc. Et nous avons utilisé les bibliothèques de Python, qui en fait, les bibliothèques, c'est purement, vous définissez votre modèle comme processus de déplacement de Python, mais par contre, à l'intérieur, tout est interaction entre agents. C'est-à-dire, chaque personne qui se déplace, c'est un agent indépendant avec leurs propres objectifs, peut-être avec leurs propres caractéristiques physiques, comme taille, comme agressivité, poids. Les touristes qui se déplacent à Louvre, américains et japonais, ce n'est pas les mêmes choses. C'est-à-dire certaines caractéristiques individuelles, et dedans, il y a un comportement purement réactif, c'est-à-dire éviter obstacles, éviter personnes. Si vous êtes dans les files d'attente, il faut prendre une file d'attente, etc. Mais à un niveau supérieur, vous pouvez définir assez simplement le comportement cognitif, le choix. On a fait le projet pour le Tour Eiffel, pour le Louvre, on a simulé l'emplacement du Japon dans la salle actuelle, dans la salle des États. En fait, c'est nous qui conseillons où le placer, parce que le projet de changement de place pour le Japon était stoppé pour 2 ans. Et on a participé dans une discussion avec les organisations pour justement le choix d'emplacement de Japon par rapport au flou et par rapport au comportement des visiteurs dans la salle. Et il y a dedans pas uniquement un comportement individuel, mais le comportement du groupe. Le plus difficile, c'est simuler le comportement des petits groupes. Quand il y a le groupe de 20 personnes qui se déplacent, il y a les guides, etc. Mais quand il y a les familles, les gamins, etc., la père s'arrête, il s'arrête aussi, ça joue considérablement pour l'utilisation de l'espace. Et dans l'espace contraint, c'est quelque chose qui est essentiel. Et les applications plus souvent, c'est le métro. On a fait plusieurs regards, des simulations, on a fait le tour du monde, même à Saint-Etienne. Le stade de Saint-Etienne, nous avons travaillé aussi, à 90. Et en fait, c'est les gares, aéroports, musées, on a fait printemps, c'est-à-dire où il y a le déplacement Python, où il y a l'espace contraint, où il y a les décisions à prendre pour se déplacer.
Thank you. Okay, yeah. So yeah, what you're seeing is a density map, and as you can have seen, you have multiple views. You have like 2D view, you have 3D view, and density map view on the pedestrians. And this is on our abstraction level. It's pretty low abstraction level, right? This is precise physical modeling of moving objects. The other libraries are rail library, and let's see. This is a basically a made-up hump yard, demo hump yard. This is 2D view where how the cars of different destinations are actually classified here on these tracks. And the classification method is hump, and you have 3D view on the same thing. And once the number of cars accumulates on a track, an engine comes from here and takes the train away. Like this train, yeah, it's gone. And the logic is described in only about 20 flowchart blocks. So this is a pretty, medium-sized logic, because you need to specify movement of rail cars and engines, coupling and decoupling, and it's only done with a very few objects and zero coding using Anylogic rail library. And just to finish with some model that again reminds you that Anylogic is very good at combining things together. This last model, railroad station, is actually the combination of the two previous things. The camera is put on the passenger train, which will appear in a second. And the pedestrians are modeled with the pedestrian library.
For pedestrian, you don't have any kind of luggage attached?
In this case, no, not.
Okay. In most station, you have most problem because some people are very...
That's a good remark. You can, let's say, model it by specifying the larger diameter of pedestrian, but it will not be visual nicely. Probably correct from the statistical viewpoint, but not. Okay. So here the two models are combined, and yeah, I think we'd better go to questions and answers. One of the questions.
Could you explain database connection?
Yeah, that's. So I have two pre-written questions. Link to Excel databases and save and restore the model state at runtime. So I'll first answer this one. Let's take which model? Ampere, subway. Let's take epidemic and clinic model. Run it. Remember the visual picture, the picture you're seeing at the moment. What I'll do, I'll say save. You can do this programmatically, but you can also do it from the. And I'll save it on the let's say desktop. This will be what I'm saving is a snapshot of the running model. The immediate state. Save. Okay. It's been saved. I can continue from here in this run. I can close this. And I can run this model again. But instead of running it, I will load the previously saved state. And here it is. So the Anylogic is capable of completely serializing the state of agents, flowcharts, etc., saving it in a file, and then restoring the state. So that was to your question. With respect to database connectivity, we have connectivity palette here with objects like Excel, text, database, and some additional objects. And what you can do, if you're interested in how this is done, go to Example Models, Models from the Big Book. And the chapter you need is Exchanging Data with External World. Here you will have all these examples. For example, text file, CSV file. In this model we have several airplanes, and we have a text file, a CSV file with plane parameters. So when the model is run, the plane's parameters and coordinates are read from a text file. You can do the same thing with Excel and with databases in Anylogic. Okay, so just to save your time, I will again refer you to the book chapter, what was it? Exchanging Data with External World. And there's a number of example models how to do that. Okay.
Exchange with database, which language of database?
For the database, you have Excel Access, SQL Server, or other, and then you need a Java driver for the database. But, yeah. Yes?
Compatibility with GIS.
Yes. You have GIS on here in a presentation palette, and an example that we have is here. Okay, this map is a GIS map. To display this map here, you have shapefile and DBF file. You can specify that agents live in geographical space, which means their coordinates would not be just real numbers, but they will be longitude and latitudes. This simple example that comes with the software shows you that you can display the GIS map and let agents move in GIS space. And I have selected this plane, and you see that the coordinates of the plane are longitude and latitude, and they're geographical space coordinates.
Can we ask you a question about the future? I mean, I guess you have a current development process.
Oh yeah, oh yeah.
What is expected about the next version of the system?
Many things. First of all, we're on the discrete event modeling side, we're making the resource management much more sophisticated than was in Anylogic before, and then currently is in any other tool. This is especially good for, let's say, healthcare applications. For example, you will be able to request, I want like either a doctor or maybe two nurses with different backgrounds, and if I want a doctor, I want the doctor that has been treating me last time. So the sophisticated resource requests, sophisticated tasks, task management, like, okay, finish this task before the shift ends, or continue working on this up to the end, or postpone to the second day, etc. So resource management, very sophisticated. Then space, we will unify all kinds of space. For example, pedestrians see walls. The entities walk along the paths. We will unify all that, so you will be able to tell the agent, okay, find the shortest path in the walls, or use this network for movement, etc. Important thing is unification of entity, resource unit, and agent. This will be one simple thing. So, like in our epidemic and clinic model, you remember probably that the patient was creating a sort of entity treatment request that was injected into the process. In new Anylogic, he will be able to inject himself into the process. So entity equals agents in our next Anylogic version. Scenario manager with a database that will you will be able to use for managing your experiments, that will remember your previous runs, previous parameter sets, so a lot more comfortable scenario manager. And, well, a lot of more new things, actually.
About the support, you've told about a big book, right? What if there are students that need the help because they have tough projects and they cannot find inside the book what they need? Do they have a possibility to call someone or something? We do support for both commercial and educational students. The policy is that we help to build models, not just to fix bugs. What we don't do is students frequently write to support things like, okay, do the project for me. That kind of things we don't do. But if the student asks, okay, something is wrong with this model, can you look? We will look and suggest what can be fixed. Or even if the student writes, I am trying to model this phenomena and I'm using this kind of construct in the modeling language, is this correct or not? We also answer this kind of questions. More questions? Okay, yeah, thank you guys for coming. Thanks for being here. And if anybody happens to be at WinterSim in Washington, D.C., we're holding Anylogic conference the next day and the next door to the WinterSim. So please do come. The last year attendance was in Berlin. There was over 100 people. So the community is growing, and you're very welcome to join it. Thank you.